So, hello everyone. We are extremely excited to be here with you today, and we would like to present to you our talk about how to empower SRE, or Service Reliability Engineering, which we practice in a special way at Swisscom with GitOps. So we would be talking about how we can automate your Kubernetes deployments with GitLab CI for the continuous integration part and Flux CD for the continuous deployment part. Having said that, disclaimer before we begin our talk. So we will not focus mostly on the tools. It's more like how we can use GitOps as a discipline or a practice. Of course, you can use all the tools in the world, right, for your CI as well as CD. Okay, so having said that, before jumping into the technical aspects, a bit about us, where we come from and what we do. So I am Manisha. I'm the SRE product owner at Swisscom.
And I'm Marco Goncalves. I'm a DevOps engineer on the same team as Manisha at Swisscom. And
since we both come from Swisscom, so I need to give you a short introduction about what we do. So that's kind of a mandate. So we are the leading telecom and IT service provider in Switzerland. What about the company size? Well, we are a relatively large family. As you can see, 19,000 people. So no bragging here, but we are really the number one when it comes to being the strongest telco in Europe. I can't help it. Yes, we have been winning several Connect tests as well as chip tests across Switzerland. We have been awarded as one of the best or the strongest brands in Switzerland. So what we do? We handle a lot of essential services like voice, internet, Wi-Fi, television, and more importantly, all the emergency services across Switzerland. Saying about the emergency services, now you can imagine that reliability is key for us. And when we speak about reliability, so most of us have already heard about site reliability engineering, which comes out of the book from Google. And what we did at Swisscom, we took it, but we adapted it in our own ways, especially because we talk about services in Swisscom, so we practice service reliability engineering. It still stands with the same acronym, so we are safe. And what we would like to achieve is service reliability through becoming more efficient. So when I talk about becoming more efficient, I relate to the first talk that we had already today morning, where we talked about how we can make our code secure. In the first place, we need to eliminate manual toil in our operations. We cannot put a guy in front of a computer in 2024 and ask them to be, hey, you have to become completely reliable, but you have to manually start inputting commands on the CLI. That won't work. So that's the goal of becoming efficient and gaining service reliability through efficiency. Second, we want to gain service reliability by being more resilient. When we talk about resiliency, we want to have our services and systems designed in a way so that they are able to auto-heal and recover themselves quickly from disasters or failures. Finally, we would like to achieve reliability through also becoming more scalable. So our services and systems should be designed in a way so that we can easily scale it up without having to add more resources or more complexity. Having said that now, today we are going to see how to harness this reliability through all these aspects of efficiency, scalability, and resiliency through a GitOps-powered pull approach of a continuous integration and continuous deployment. So, a lot of jargons here: GitOps, pull, CI/CD. So let's start one by one. What is GitOps? We've all have that by the definition book, and this is what I would like to start with. So it's kind of a deployment approach which would help us in the infrastructure or the application management part, where we will maintain our source code, which is usually stored in Git repositories, which are version controlled, as the main source of truth. That's it. Now, when I talk about CI/CD, it could be possibly a push approach or a pull approach. So let's start with the traditional pull approach of a CI/CD. So usually we have a source code which is in a version control system like Git. Then we have a CI pipeline, which has stages like building, testing, releasing your application version to a container or an image registry. And finally, we have the CD part, What happens in a traditional push approach is that usually we have a human guy, right, who checks that if there is a new version of your application that is visible on the container registry, and then pushes it to your environment of choice. So this is the traditional approach. So far, so good. Today, we would like to be focused on the pull approach, where instead of a human operator now, we really have an operator, for example, in the Kubernetes cluster, who would be responsible to scan for your new image versions or new application versions and deploy it to the environment of your choice. And this is the pull approach of CD, which we will see with Flux, by which it is known. Now that we have talked about the CD part, before we delve deep into the CD, which we will do with a lot of fun, let's have a quick look at the CI part, because we will use this when we show the demo and try to bring all the pieces together.
So as Manisha said, the CI part will remain unchanged, whether it's a pull approach or a push approach. Here we have a standard pipeline overview. Now, note, we will do the release before the test, and now you will think, what are these crazy guys doing? So, but this is due to internal requirements. Also, we would like to isolate the build process from the test environment, and then we will like to do a validation of the image in a step later. So, saying that about the build and release step, we will use Canico executor to run a Docker file. This Docker file will build a simple Flask application, and as well with Canico, we will push it to our container registry. Then, next, test step. We will scan the image to scan for vulnerabilities in our image or libraries that we are using in our Docker file. And then, a second step, we will validate the image. And how we will do this? So for the container scanning, we are using the standard plugin from GitLab, the container scanner. And for the validation of the image, we are pulling the image from our container registry and doing simple health checks. If any of these tests fails, what will happen is we will remove it from our container registry. And how we will do it? We will use the Canico crane that command-wise works a little bit as Docker.
Cool. So now we have the CI part done. Let's try to focus on the CD part, and as I said, we will look at Flux today. So here there are two aspects which we would like to cover. One, where Flux is establishing Git or the source code as the only point of truth. And the second part is where we are able to see the pull approach of the CI/CD. So let's begin with the definition here. Yes, it will help us to automate our Kubernetes deployment every time you change one single line of code. Let's start with the bootstrapping process. So here, bootstrapping means we are just going to install Flux onto our Kubernetes cluster. What's the output? It installs some controllers. It will create some custom resources, and all of it, we will have a better look, a detailed one in the next slide. And it will establish a connection in between your Kubernetes cluster and the repository, the Git repository where your source code is stored. So here I would like to provide you one simple example of a bootstrap command. So you already see we have some specifications about pointing to the Git repository where you have the source code. So possibly the GitLab instance URL, what's the name of the GitLab project, what's the GitLab group. Finally, also the registry from where you take the Flux image and deploy it onto your cluster. Then we have some authentication specification as well, and that's important. We will see it also in our learnings. So here I'm using a token authentication method by giving it read and write permissions, which mean I am authorizing Flux so that it is able to read as well as write to my source code. You can go with a simple deploy token. This depends upon your requirements. Deploy token from GitLab comes with default read permissions. What you see in the last line are some extra components, and this is the image reflector and the image automation controller, all of which we will also have a look in the upcoming slides. Okay, so let's dive a bit deeper into the Flux controllers and the custom resources which were installed. So what we have at the moment, we have a GitLab project where we have our source code. We have a cluster which we bootstrapped using Flux. So what's the output of that bootstrapping process? Number one, we have a source controller which was installed, and this guy here is responsible for the reconciliation of a custom resource called Git repository. If you would like to see how the config looks like, by the way, these are configs which are auto-created by Flux, so I'm not going to create it manually. But it's interesting to have a look at how the config looks like. So as you see, it specifies an interval. This interval is the frequency at which the source controller is responsible to check for your changes in the source code in your GitLab project. Of course, you can mention which branch you want to. So if you want to segregate your deployments, for example, deployment environments like dev, test, staging, or prod, you can do it in a different manner for your individual branches. It also uses a secret reference. So if you go back one step, where we mentioned the authentication part, we were using the token auth. And when we use this token auth or the deploy token, what the bootstrapping process does is it encodes it as a Kubernetes secret, or encrypts it, rather, is the right word, as a Kubernetes secret. And then finally, this is the secret that will be used during the reading from the GitLab project. Okay. The next part, we have the second controller, which is the customized controller. And this is responsible for the custom resource, which is called customization. And here as well, we have the config. As you see, we have an interval at which the controller is now responsible to apply those changes to the cluster. So first one was reading those changes from our source code. And finally, the customized controller would now apply those changes to the cluster. Here, of course, it is referring also to the source code CR, that is the Git repository. Now, so we have established the sync in between the GitLab repository and between our application deployment onto the cluster. So now if I would like to change my application manifest, or now I would like to update my application manifests, that's basically the path which would be monitored by the customized controller and the source controller. With the help of reconciliation of these custom resources, that is customization and Git repository, my application deployment would be updated. So far, so good. What we don't have yet is the connection in between the CI part and the CD part. And for that, we will use this guy, which is called the image automation controller. So what does this guy do here? So of course, the CI pipeline would release new versions of my applications, right, on the container registry. And this guy here would be responsible in order to automatically update my application deployment on the cluster through the reconciliation of 3 custom resources here: image repository, policy, and image update automation. So how does this look like on the config part? Very simple examples, as you see here. Image repository, just like the Git repository, it's pointing now to a container registry. It uses a secret, usually a Docker credential, which is encrypted as well as a Kubernetes secret here. Here it just has the read permissions, which are necessary because we just need to read the image from the container registry. Then image policy, you can define the method by which the scanning of the versions for your applications would take place. So if it is a semantic one, if it's an alphabetical or a numerical one. And finally, this image update automation guy is the one who is responsible now, will deploy the changes to your cluster. But how does that deployment of the changes to the cluster work? So let me just try to put all the pieces together. So we have the CI pipeline. It releases a new image tag, so a new version of your application onto the container registry. This will be taken into effect by the image repository, which finds out, okay, I have a new tag now, according to the policy that you just defined in the image policy CR. And this guy here, the image update automation, would be now updating the deployment manifests which reside in your source code. That's exactly the reason why I had to give Flux the read-write permissions. So once the deployment manifests are updated on the source code, this will be effectively taken into account by the source controller and the customization controller. And finally, your application deployment would be updated. So far, so good. We saw the theory. So let's try to see some GitOps in action. So we will begin with the CI part here, which Marco just showed. First, I would like to show you what's the current setup here. So we have a simple Flask application which returns a welcome message, something like this. The last version of the image which is being used is 1.8, as you see. I would like to also give you a view on the cluster part. So you see there are 2 pods, so the replica is 2. We have exposed Flask as a service. We have the deployment running. Let's quickly check how it looks on the deployment.yaml. What's the current version? So it's 1.8, just like we saw on the container registry. We have configured an ingress rule as well, so that we are able to see how the Flask service is working. So let me just get the name of the host. So you see this one is the name of the Flask host, which I have configured on my local host as an entry on the DNS part. So this returns the exact message which we just saw on the application config. Okay. Next, what we are going to do is we are going to change now only one line of code on the application.py. So let's change something to arbitrary. The thing that we would like to establish here is that, of course, we are changing this, and then we will trigger this pipeline manually, but you could trigger it as well in an automated way. That's possible through GitLab. And through one single line of change in the code, we should be able to see how the deployment kicks off, or the CI/CD kicks off. So I have saved it now, and I would now navigate to the project, and we will, let's say, trigger the pipeline. So the last version was 1.8. I would upgrade it to something of a higher minor upgrade, so 1.9. And this triggering, exactly, we could do it in an automated way from GitLab. So I am doing it just for the sake of this demo. And yes, now let's navigate to the part where the pipeline was done. We did some container scanning, and the new version of the image is visible on the container registry. What we would like to see now is on the deployment manifest of my Flask application, if the image was now using the new version. Yes, it is. And we would also like to verify on the Flask host if it is displaying the new message that we just changed on the application. Yes, it is. What is the magic that happens behind? We could just get hold of all the resources here. So first of all, the Flask app repo, as you see, was responsible to scan the tags. Second, the app policy was able to now update my application version from 1.8 to 1.9. And finally, the Flask app automation, which is the image update automation, then wrote to my deployment manifest, and I have that deployed on the cluster. The second part would be to see if GitOps is able to override some accidental or unintended changes on the cluster. So if you remember, we had 2 replicas for our Flask application. So I would just go into the cluster and do this manually now by changing it to 3. And interesting part is that it will spin up a new pod, right? So this would, now we would see like it has a new pod running since 5 seconds. But immediately after, what happens is that, of course, the reconciliation takes place. Also depends upon the frequency at which you have configured customization and the Git repository to do your reconciliation. So it will start realizing that, oops, that's not what I have in my source code. So it will start terminating the new pod. And after a few seconds, of course, if you run the command, you should see that the 2 pods which still keep running are the old ones. Okay. So with that, let's try to recap a bit and see if we were able to check a few boxes when it comes to the efficiency and resiliency and scalability part. For the efficiency part, yes, we could do a hands-off deployment with one single line of code change. For the resiliency part, we exactly saw just before this that how the self-healing nature of GitOps allows us to not have unintended changes that are done manually on the cluster. And finally, for the scalability, we are able to decouple our deployment logic with the release cycle. So kind of the same Git repository and the customization, custom resources helps you to build services on top of what you have instead of going on adding too much of complexity. So a few learnings here. about the access credentials, which are quite important, it's kind of recommended that we don't use a GitLab personal access token or any personal tokens for if you are in a productive environment. Second, of course, storing credentials in plain text in the source code, as we know, is not something that is it's a no-go. So we have to go for, we could possibly use GitLab project access tokens. We could use Kubernetes secrets, of course. Then talking about branch protection and pull requests, I think these are very important. So probably you would not like to have a highly automated pipeline for your production environment. You could separate that by having environment. Per environment, you could have it as branches, and you can ensure that your production environment still invokes a manual review instead of having this automated for the prod. And of course, pull requests so that humans are able to review what you have submitted as a pull request. Then image scanning, as you saw in the CI part, this is something we could not skip, right? We don't want images with insecurities to land up in our production environment. So that's kind of important. Then clear image automation policies to prevent this unintended automatic update of your deployment manifest. It's very important that you define clear automation policies. Probably, like if you want to do it for a production environment, I would also restrict it to have upgrading my deployment manifest only with tags if they are stable or something like that. Not always updating my production environment with any version release that I have. Then overusing automation controllers, probably also a no-go, because if you check the container registry or your source code every 30 seconds, probably it will put a high constraint on your resources, on your limits on the cluster. And finally, do we use GitOps for all and everything just because we have to automate, just because we have to have everything as code? Probably not. That's not the recommended way to go. We have to assess if it is suiting our use case or not, and proceed only if it makes sense. With that, I don't know, Marco, is that it?
No, it's not yet. So we have prepared for you a workshop where you can observe this GitOps automation in action. This workshop will cover the setup or a local setup of a K3S cluster and bootstrapping with Flux. We also have there a step-by-step guide, so you don't get lost. And please make sure that you have a GitLab account, because there is always a question. And yes, we are ready now for your questions. Meanwhile, you have here the QR code to access the workshop. Just try it out and give us as well your feedback. And thank you so much for your attention. It was really a pleasure to be here with you. And yes, thank you so much.
Yeah, let's give a round of applause. Thank you. Do we have questions from audience? There's one. Okay.
What if you have maybe a bunch of Helm charts, well, let's say 20, and then you're considering this, is it worth it, and what do you do with those? And let's say, for simplicity, they are very similar, so you have service, deployment, ingress definition. Like, do you rip it out and like put it out of the Helm charts into different structure, or do you somehow just deploy Helm charts through Flux? Should you even mix it? So can you comment on that?
Yes, so I basically have a good option here, something which I would like to now try forward. So if you've seen the latest release from Flux, it comes now with the Flux operator, where you can have, so this was released just, I think, in the middle of October. So they came up with the new Flux operator, which would be effectively managing the lifecycle management, the whole bootstrapping process, the installation, everything for all the Flux resources. So it's typically like what Helm chart does, but we don't have to take care, or we don't have to have any headache about the whole lifecycle management of the Flux components. So I am looking forward to try that out, and I would highly recommend that if you are interested, probably that would make sense. Because then just like we did, and you saw that there were like two outputs of the bootstrapping process, the source controller and the customized controller. Of course, those things I did not have to manually do, but when it comes to the image automation, that's where the manual part comes. Of course, you can also create the configs by taking advantage of the Git repository and the customization CR. That's typically what I also did. I specified these in the source code, and they got created as custom resources in my cluster. But probably this is also something that we can abstract and have the abstraction of GitOps more through a Flux operator.
I do have a question. Like, I wonder how you handle unhappy paths. Let's say your stuff gets merged, and then the pull is coming, and all the tests pass, but like deploy fails. Like, is there like some additional like orchestration happening to revert the chains in main branch and etc.? How you handle that?
Yeah, so this is the part which would say that which would invoke the extension of the CD pipeline, where we should be having smoke tests. So we would have smoke tests, and basically to check if the deployment went through as we said, and we have then the possibility of rolling it back, if that was your question about.
Yeah, kind of, yeah.
And if you are talking about how would you do it on production, and how would you do it on, let's say, a dev or a staging, then yes, that's something else. We would recommend not to have a total, let's say, a kickoff with one single line of code change and you deploy it on production, unless you're super confident. Then, yes, there are certain configurations which you can have in this image update automation, which gives you the possibility of doing a manual approval process only for your prod environment. So you don't have to do it for dev and stage, but you do it for prod.
Okay, thank you.
One small comment about Helm and Flux CD. So Flux has Helm controller. So we use that. We have Helm releases, we use Helm charts, we deploy via GitOps with Flux CD. So that's absolutely possible and doable. Google. Thank you.
Thank you. So let's give a round of applause and thank you.